Hi, everybody. Thank you for joining us for IFMA's webinar series. Today, we're going to be taking a look at navigating the complexities of high-performance building design, ASHRAE's Guideline 36. Before we get started, please let us know where you're watching us from. I'm Kim Jackson. I'm with IFMA, and I'm joining you from Houston, Texas. We also ask that you please like and share this webinar so that others can find the great content that you're about to watch. So without further ado, let's go ahead and get started on our webinar. It is my pleasure to introduce Brad Bonfilio, who is with IFMA's partner, Schneider Electric. Brad is bringing 25 plus years of experience in the building solutions, security, and energy management industry. Brad holds a BS of Industrial Engineering from the University of Florida and an MBA from the University of Dallas, where he continues to reside. So he's joining us from Dallas. Currently, Brad is the Consultant Solution Architect Director, managing a national team that provides high performance building management solutions focused on mechanical, electrical consultants, and facility managers and building owners. He is a subject matter expert for OT and IT technologies involving buildings management systems, including architectures, open protocols, mobile apps, fault detection analytics, semantic tagging, and Division 25 use case solutions for healthcare, data centers, real estate, higher education, and government customers. Brad, you certainly cover quite a number of the various industries that IFMA's members support, and we're really excited to hear more about ASHRAE Guideline 36. So I'm going to hand this over to you and look forward to learning more with you.
All right, thank you very much, Kim. I do appreciate the nice introduction there. And I wanted to go through a topic here. And by the way, welcome everybody across the country, wherever you are. I'm in Dallas, Texas, and obviously Kim's down in Houston. And so wanted to share with you a little bit about ASHRAE Guideline 36. And ASHRAE Guideline 36, I'm going to just start off with, it is a rather complex sequence of operation for HVAC. I'll go through some of the guidelines in here. We're going to cover this as a high level. By all means, are we not getting into the weeds, detailed weeds of ASHRAE Guideline 36? My encouragement is to go on to ASHRAE's website, go ahead and pay for a copy of Guideline 36 and read the material yourself to get into the weeds and the nuances of the sequences themselves. This is sort of a high level to go through just the highlights of it so you know what it's about. We're going to have here today an hour presentation. It should be about 50 minutes with about 10 minutes of Q&A allowed throughout it. And at the end as well. Every so often, I'm going to pause and look at the chat. So if you put questions in there, I'll try to answer them as we go through it. If not, I'll pause at the end and we'll go ahead and go through some questions then as well. We recently also presented this for ASHRAE on behalf of ASHRAE. And I also wanted to note that we actually have one of the members of our team, Raf Sawaki, who is actually on the ASHRAE Guideline 36 committee, who has actually helped me put this presentation together. And so he actually is one of the experts that actually helps write this guideline. So we'll just jump right in. So we're going to go through a little bit of what it is. And as I explained, it's high performance, energy efficient building management control systems. And they want to get to the sequences. Typically the sequences in the industry are not the norm of high performance. They're typically the opposite of that. And so the whole goal with ASHRAE was to develop a sequence that everyone could follow. The committee was joined and started in 2018. So it's been around a while, but it's been in several iterations. Today, we're going to go through the air side because that was developed first as their standard. Since then, in 2021 is the latest, and they've actually updated it now they're just now getting into revisions from the original air side, and now they're starting to work on the water side. So eventually you'll have chill water, hot water applications that are going to be released here shortly. But today we're going to go through the air side, which of course, as you know, the air side relates to the water side. As you improve one, it's going to affect the other. So my assumption is that's why they started with the air side. And this standardization of high performance sequences, the whole idea of this was, and this was really what the committee wanted to do, reduce engineering time, and I'll explain what that means. Programming, standardization, commissioning, and energy consumption. And the big part of this was not only energy consumption, but actually indoor air quality to improve it. And you'll see one of the examples we have on the air side actually will help actually improve indoor air quality above of what the normal standards are. So a little bit on who is Schneider Electric, why use Guideline 36, how does it go to market, things to look out for in your specification, how does it work, and then again, recap, we'll have some time for Q&A as we go through this. So a little bit about Schneider Electric. So over the years, we've acquired many solutions and products and software solutions over the span of our company. And as you can see, the different brands we have on here. So a lot of times you might know us better by our brands than actually Schneider Electric, Squirby being one of our bigger ones in the electrical space. But as we bought and acquired these companies over the years, one of the challenges we've had was, how do we keep up with IT standards? How do we keep up with all the different Windows applications? And so what we did is we created an EcoStruxure architecture that links all of these products together, all these technologies. So anything that's intelligent that Schneider sells, the idea is to plug and play that into our EcoStruxure architecture to be able to share data across all the technologies. And this becomes a really important when you get into stuff like the Vision 25 specifications in the construction market of connecting products together. We're also extremely proud that last year we were rated the most, actually last year, and it actually was awarded this year, the most sustainable company in the world, which is saying a lot considering when you look at the list, there's Microsoft, Apple, and other companies like that on the list. So we were extremely proud of that, which is actually saying a lot too, because we manufacture a lot of these products and software. So when you think about it, we're having to apply our energy savings and sustainability plans right into our manufacturing facilities, which is why we're so passionate about Guideline 36, saving additional energy. So what is the world looking like? What does a building look like? And I'm saying building interchangeably. This could be a hospital. This could be a life science facility, though I would caution you on those two. When you think about life science, you think about healthcare. Guideline 36 was meant for a building. So you're going to have to interchange those as we get into it accordingly, because you also have regulations that you still have to follow within those. So again, that's why it's a guideline and not a standard. So if you think about the world's emissions, they come from buildings. Again, interchangeable to other facilities, but that's where all the CO2 comes from. You could see 30% of that is wasted within buildings, hence why we're coming up with Guideline 36. And 90% of our time indoors. This has shifted a little bit, obviously, with COVID. And a lot of times it could be in our office, it could be in a customer site, or it could be at your house. Either way, you're still indoors. So what is it? The whole idea was to help, and this is one conversation I have with engineers a lot and facility managers. When it says help reduce engineering time, that's an interesting one, because a lot of times folks will say this will increase my energy engineering of the site. And I'll explain what that means in a couple slides of what the intent was of this guide. The other part of this was to standardize and actually look at commissioning time. So the idea is, if we documented the sequences, we can then easily follow them with the commissioning to verify what it needs to look like, versus having something custom each time. And then, of course, one of the biggest energy things, or the biggest factors, was the energy consumption. The other reason was the indoor air quality. Okay, that was another piece of this as well. When we get into CO2 control and demand ventilation, we'll talk about that in a second here. But these are all the things of the original intent from the ASHRAE journal. So I always like to throw a little bit of some entertainment out there for you. So when you think about perceptions, and I'm relating this back to Guideline 36 on a custom sequence versus a standardized sequence, this is traditionally what the customer explained they wanted in their building, and that could be related to performance. This is how the project leader understood it. This is how the analyst designed it or programmed it. This is how they wrote it. This is how the consultant described it. This is how the project was documented. And I always get a chuckle out of this one because it's never really documented very well typically. And for those out there in the facility management, which IFMA, you have a real challenge with this of how things are documented. Hence why Guideline 36 is important. What operations installed, how the customer was billed afterwards, how it was supported, and what the customer really needed, right? So again, there's no wrong in this. It's just faults of perceptions of one group to another and what you really needed as an end result. So hence, this is what the sequences are trying to do in the standardization. So why use it? Because what the current state of the control systems is they're typically dumbed down to make it simple. A lot of times that's to reduce cost, and especially around, we want to make sure we get a low bid situation. We want to keep our costs down, so we want to make it as simple as possible. The other reason, the other current state of why it's not being used is a lot of packaged equipment. So the actual Guideline 36 was related to chilled water, hot water applications. It is not related to DX units, rooftop units, that type of stuff at this stage. And so one of the challenges you have is when you're writing these sequences for high performance and you try to relate those to rooftop units and meeting some of the energy codes, there's a real challenge there because the application specific controllers that might come with the units can't do those sequences or are not programmed to do those sequences. So this is very common in the market. So this is a real challenge for meeting this guideline. I'm also going to say even outside of DX units, and you think of the building management system, there are two types of controllers out there, application specific. I say there's two, there's multiple, but the key ones we're going to focus in on is application specific controllers as referenced by the BACnet testing lab, and then advanced application controllers also referenced by the BTL lab. The differences are application specific are typically configurable and they may not have the flexibility, the memory, or the capability to actually implement Guideline 36. So this goes back to, and I think I have a couple slides down the way that talks about your specification. You really do need to check with Guideline 36, or if you have an existing site with an existing BMS, the application specific controllers you may have, especially like on terminal units, may not be able to implement Guideline 36, and you're going to have to do a lot of reworking of programs to try to make it work. So that's a real challenge in the industry right now. The higher performance sequences in the past, they avoided that because it was custom and it was not verified and tested. The whole reason you would use Guideline 36 is they've been verified. ASHRAE has developed these as their standard. They've been tested, validated. So the idea is we can reduce that risk of using a high performance sequence, but yet have it documented and tested that it works. It's still relatively unknown is why a lot of people don't use it, or it's too complex. So let's go through some of the examples of some energy savings as we look at this from the industry. So I'm going to give you some examples of some folks that have worked on this as doing a study. One of them was Berkeley Lab, where they actually looked at a medium-sized building. They found the average energy savings using Guideline 36 was 31%. So this is This is when you look at building management, the rough rule of thumb has always been 10 to 15% energy savings when you use a BMS system. Well, this is 31%. So this is not like a smaller number. This is a bigger number you're dealing with these sequences. Let's look at another one. Here's a California codes and standards. This one here was interesting because they looked at if the building already had a modern building management, what would be the added benefit to adding Guideline 36 to either that system or with a new one? And they rated it as 12 to 23% energy savings. And again, this is assuming they already have a BMS in place. So I thought that was a really interesting one from California. And then the last one, Journal of Building Performance, their simulation they ran on it. Again, we don't have a lot of case studies out there yet because it's just an evolving specification or guideline, excuse me, that is coming out. So a lot of these are actually simulations. In this case, they tried it with the average, the same results as what Berkeley came up with, 31% energy savings based on that. So what are the things that are involving Guideline 36? So the current state of sequences, we want to try to standardize. We want to reduce the risk so that it's documented. We showed that variable perspectives of what we look at. We want to keep the risk as low as possible. We want to look at yet high performance and then compliant, right? Compliant with the energy codes. We see that over the time, what's going to happen is a lot of these standards, ASHRAE 90.1, 61.2.1, 55.13, and even Title 24. And in fact, Title 24 is referenced quite a bit in Guideline 36. So I think California is kind of, if you saw the articles on this, California is kind of leading the way, and we're going to starting to see this adopt in other areas across the board. So to be determined on how this goes through, but let's look at it from Steve Taylor for Taylor Engineering. He was one of the chairmen of the original chairman of Guideline 36. His feedback was, we have identified the best way to break into this cycle of manufacturers. So the way that Steve's looking at this, and the reason that the ASHRAE committee was looking at this is the manufacturers to pre-develop the programming without waiting for the dealers to actually request it. So this is interesting. So this is, remember we talked about the engineering would be kind of more complex to do to develop this. The intent is the manufacturers like ourselves at Schneider Electric, to develop Guideline 36 for our dealers, for our integrators, so that they don't have the added cost of doing this. This was the intent of the original committee. And then this is the most efficient approach. So sequences are only programmed. So once you develop this, you only have to do it once, right? And you can repeat this since it's documented of what they are, reducing costs and improving indoor air quality at the same time. We have some engineering tools within Schneider, and you'll have to work with your current providers to find out what engineering tools they have. I can tell you all ours are built around Guideline 36 as they become available. And then the great quote from our engineering team was, why wouldn't we use them if that's the best in class in the industry? Why would we go back? Because my question was, do we have options for the basic sequences or the high performance sequences? And we just chose the high performance because we wanted to follow ASHRAE Guideline 36 as much as possible, and then give that over to our integrators, right? So that was the intent. That way you don't have an added cost on your job when you see Guideline 36 to meet that standard. It should be built in, and there should be minimal tweaking to be able to make that work. So how do you accomplish this? How do you specify it? Now, I'm going to go back from a building owner, building manager, facility manager. You could ask for it, right? You could literally say, I want to make sure this follows the latest ASHRAE standards, whether that be ASHRAE 90.1 or whether it be Guideline 36. Just asking for this is a way to start. If you're an engineer, you can copy and paste text from the original sequence, right? And edit it as needed. Again, it's a guideline. Or you can actually go into the Guideline 36 and reference section by section by section how you comply. And as you'll see when we get into what the high level is in the next few slides, you'll see there's different sections of it that we're going to comply with. Which sections is the engineer or designer work referencing, right? So we need to know that. The next one is you could just write use Guideline 36, though we don't recommend it, and you'll see why when we go through what they look like. Just because we're not sure, we need to be known in the market. Our integrators need to know which ones we're following, which ones we're not. Again, it's a guideline. Or another way you can do this is, and we'll go ahead and put this in the chat. Our team will actually put this in the chat where you can actually go. There's a spec designer tool. That's at smartwaretech.com, and you can actually go into there, and then there's a section in there you can actually do the sequences and points list within the tool to help you create those sequences if you need help. Or there's a support line here you can actually send in and request support from us. All right, things to look out for. Design considerations. This was what I was hinting to earlier, where mature product lines may not support Guideline 36. Memory, COV is change of values. That's a really big deal. Application-specific controllers by the BTL profile don't support or don't have to support COV. And if you think about that, that's change of value. If you don't have that available, you're going to have to ping the network even more than you had normally with just using Guideline 36. And it's going to pretty much bog down the network. So then you have a real challenge of, will it even work? That goes back to that theory of, can it even work or not? The media may be an issue. Most of the existing sites out there are MSTP. When you're talking Guideline 36, you're much better off with the IP because of the speed, and you'll see why as we go through the standards here in a second. And again, COV impacts both of those. Manufacturers, things to look out for have already begun. We talked about that already. We're testing, validating them, documentation sequences. Here are some examples of how you could request this. The Perimeter BMS shall fully agree to test the Guideline 36 sequences and so forth at no extra cost. Those are the type of things you can start listing out now. And then there's actually sequence fault detection in there as well. So I'll show you that in a second. So let's just dive in. So we're going to go through the general logic of trim and response is the first thing we're going to talk about. Then we're going to talk about ventilation and demand control. And then we're going to talk about how to control some of the air handler logic. And then we're going to talk about alarm degradation, and fault detection, and what's built into the actual guide itself. So the first one, we're going to do trim and response. And trim and response, by the way, is already mandated by Title 24 in California. So this just adds to the same thing that's already happening in the market. So typically on trim and response, and I'm going to give you this in layman's terms, is what's going to happen is you're going to look at every single terminal unit. And what normally you do is control static by 2/3 of the way down the ductwork. Well, that is more of obviously looking at all of them being equal, and I'm going to control off the 2/3 of the ductwork. So there's no real advantage to one box working differently than the other. It's looking at that one static point. With trim and response, what we're actually doing is looking at the damper position and the CFM of every single terminal unit, and actually then providing which one needs the most air. So now we're putting priorities to that and giving that feedback to the air handler so we can actually reset the static pressure and reset the speed, which is the static pressure, and you're actually adjusting the temperature. So now you can do temperature resets. I'll talk about in a little bit of how it actually gives commands or responses. It makes requests for, I need more air across the network. Remember, we were talking about bandwidth, right? So this is why it becomes important, is we're having to give that message all the time, and it'll go through an ignoring process where it looks at the zones, puts a weight on each zone. So now the more critical zones are the ones that are going to actually get the air that you need, or the temperature reset. And this is sort of what they're showing is the static pressure reset. And this is actually showing you the requests from the zones on which ones need more air or less air. And again, I'll show you the zones in a future slide. The point is you're looking at different control mechanism now than you had before. We ran this by one of our eco experts a couple of weeks ago. And when they actually looked at this at first, they thought it was rather complex to look at. But once they dove into it and realized this is actually a better way to control a VAV air handler than the traditional method. So outside of that, they actually thought this was far superior than what we were doing with 2/3 of the way down the ductwork. So it was interesting how one of our eco experts started to embrace this and realize, wow, this is a better way to do it. And you'll see that on a number of others as well. The next one is we're going to go into the thermal ventilation demand control and then the logic and how we set that up into the zones. So when you're determining demand ventilation, you want to look at, again, we kind of talked about the lowest VAV box and what the airflow set point is. And then what you're going to do is set up the minimum airflow. And again, there could be Title 24, it could be ASHRAE 60.2. That's typically set up in the control drawings by the mechanical engineer. The lowest possible VAV set point other than 0 is typically set up when you're doing the setup of the programming. And I'll explain what these means in a second. And then what if the zone is a minimum rate is less than controllable? So this happens quite a bit where the actual set point that we want can't be controlled to there. And I'll show you an example. What happens in this example at the bottom is if you have a ventilation rate of 33 CFM, but it's only controllable, I mean, I can't control it less than 100, then what they do to get down to that 33% is they actually duty cycle it. Okay, they'll on and off period. So it'll actually go to 0 and then it'll go back up. And so what'll happen is over the time, you'll hit the average of the 33 without actually being able to control from there. So this is a different way that we've done this before on VAV boxes. Typically, this has not happened. Typically, it's only controlled to 100 and not lower than what it was supposed to be. And this is a way to do that. So it's the average ventilation. Again, another scheme that we've never had before. The demand ventilation for VAVs, this is an interesting one. So as you open up the outside air damper and you've got max and min cooling, what happens is this is part of the improving indoor air quality is normally when you have a CO2 set point that's already been set up by either of the codes or an example, Title 24, they'll set up what the parts per million is. We're actually going to take whatever that set point is and we're going to subtract 200 parts per million and we're going to control off of that. So what's happening is you're actually improving the demand ventilation on that above and beyond what the code allows. So this is back to, we're going to use typically more energy to do this, right? Because we want to increase the indoor air quality of this application. So this is one, and again, if you look back at the articles, the energy savings on average was 31%. So that includes actually doing this as part of the study. And so you get an example of what will happen if the control loop is actually disabled. You'll actually get a 0 if it goes down. So it'll actually go up from all the way from 0 all the way up to the max of set point. So we talked about zones a little bit. So we talked about trim and response. This is typically what happens. This is not Guideline 36. So this is typically what happens when you get into Guideline 36 and you've got a typical application that doesn't involve this. So you typically they consider all the zones to be equal, okay? All the zones are overcooled because of the high mins is typically what happens. That goes back to the reheat. And then you get a single airflow set point is used for both heating and cooling. That's pretty normal with how you set up a VAV air handler system. Static pressure reset only uses the damper position. The single control loop for both heating and cooling, only one, there's a dead band between it. No differentiation between electrical rooms, storage closets, and so forth. So this is the traditional way you would control an air handling unit. And this is the way you do this with Guideline 36. So you'd set up the max CFM and you would pick what area each one of these covers. And then we would actually go in and try to classify which ones are more alike each other. Okay. So for example, office conference rooms would be a zone 1, common areas lobby, we would group these as a group to zone 1 because they're very similar in nature. And then the lab areas might be zone 2, storage closet might be zone 3. And you can see where I'm headed with this is we can actually put priorities to these then on which ones are actually going to get the reset signal and which ones need more air the soonest. And then we actually put a weight to them. Okay, this is the weight of the factor. Remember, we talked about the ignoring of the ones that are not as high priority. And then the other thing we do is put in a cooling set point and a heating set point now. So we actually have 2 of them that we hadn't done before. So the trim and response, this is how that actually works by looking at the zones, putting in a weight, ignoring the ones that don't mean as much, and looking at the ones that are more critical. So as we group these assignments, there's some rough rule of thumbs to think about on this, is each zone still needs to be controlled by a single air handler, right? So you can't take a VAV box from a different air handler and try to zone it to another air handler. They still need to be on the same zone. Rooms, like computer rooms, network closets, obviously they need to be still assigned to a group, but they don't need to have a group number. Okay, they could set up different restrictions depending on what you have to do. Again, you'll have to look at the facility to see. Hopefully, if it was in the design, it was maybe computer rooms, network closets might actually have a dedicated unit for it, like a VRF or a DX unit that actually serve that area. That way, you don't have to try to group it into the zone with the air handler. But again, it depends on design. Shouldn't expand floors. And so you shouldn't have one VAV box on a floor with an air handler and then try to sync up a zone or link a zone on another floor. Obviously, that doesn't make sense. For each one needs to be dedicated because you're resetting the static pressure and you're resetting the temperature, and you obviously want to do it on the air handler affected by the units that are serving it. They don't want to get too big into the zone group. So 25,000 square feet is the maximum on the zone group. So you don't want to have one terminal unit feeding a vast space and another one feeding a vast space. And both of those add up past 25,000. So you obviously want to have it to where the zone is divided up, is the point of this. You don't want to have one being a bigger zone. So look at that across, and that's with the ASHRAE. You can see the references to the ASHRAE standards we have. Obviously, tenants are important, so you'd have to factor in who's in the building and how you're going to group them. Obviously, if you have a tenant-occupied building, you may not want to group one tenant with another tenant, so you may want to individually do the tenants. Another zone should be should not be a member of more than one group. So you don't have tenant in this group, tenant in that group, and then have a tenant in another group. So be looking at how you zone that. Exhaust fans do need to be linked in with the group. And then miscellaneous equipment must be included if it makes sense within the group. So there's some logic you have to do to this to be able to set all this up. And these are all referenced in the guideline of Guideline 36. So let's talk about air handler control. When we're looking at it, this is a traditional, and I'm going to put non-Guideline 36. It was very common in the past to have, especially on low bid situations, when you might have an actuator on each damper for outside air, return air, and exhaust, but you only have one output going to those. There was nothing that specified you had to have independent outputs for these. One is doing the same signal to one of the other. Typically, you do this again, low bid situations where you have one output because you're saving on cost of upgrading a controller. There's a lot of reasons why you would do it this way. You've run out of IO points. Whatever the case, happens more than you think. And when you do that, what happens is when you do control like this, your mixing box, the differential pressure across it looks like this when you're doing this, because you're assuming they're all proportional in nature. Okay, so let's look at what Guideline 36 does for outside air control. It looks at it as each individual damper actuator has to has an output from the controller, which means 3 outputs instead of 1. And you're going to control each one of these independently. And the idea between that is you're actually changing what it looks like now in the mixing box area, right? So now you're getting less differential pressure buildup and you got better control. And one of the ways to look at this is I like to look at it as, if you think about opening the outside air and exhaust air, if you think of them being proportional, well, not necessarily. You typically want to have separate outputs for exhaust air based on the building pressure, being typically a slightly positive pressure. Well, there may be a time where you don't even need to open that, depending on how much leakage you have in the building, to where you might have outside air come in and do very little exhaust. So that's just one example of controlling those individually to where you can actually gain an improvement in efficiency and performance. But this gives you an example of, and this is something where I had like an aha moment where I didn't think of this either. When I've been in the controls business for years, I've had a lot of times where you might have 1 output or 2 outputs for all these dampers. Okay, so let's go now so we went through trim and response, demand ventilation, zoning of the air handler controllers, and damper control for outside air. Now let's go through the alarm management and fault detection. So overall, one of the cool things about Guideline 36 is they actually do list out all the alarming that's required in it. So if you're an engineer or a facility manager, instead of having to always ask for these or make sure I remember to put them in my spec, these are actually standard in the Guideline 36. So you've got different alarms in here with the VAV, the air handler, and I'll show you later on why these are important, because if we got to standardize on the naming of these, okay, and we must define them ahead of time if we're going to actually do fault detection, and I'll show you that in a little bit. So this is where we're having to find these first within the guideline. So it went into VAV, air handler, boilers, and chillers, and what each of these mean and how they're defined within the guideline. And a lot of these relate back, if you get into the semantic tagging, very much related to that, where if you don't set up your naming standards ahead of time, how are you going to be able to measure or affect those points if you don't know the standards? That goes back to third-party analytics. That goes back to AI. When AI is getting more and more developed, that goes back to, if you don't have a naming standard of how you set this up, how are you going to get the information and do something with it that's meaningful? That's where this is actually defining these alarms in Guideline 36. So traditionally, what happens if you don't have Guideline 36, and you all know this all too well as facility managers, you get a chiller alarm first. Well, what does that happen? You get air handler alarm shortly after, you get the pump alarm, you get the VAV alarms, and then you get the room alarms, right? Well, that's a lot of alarms to go figure out what is happening in the space, because all this comes in at one time, right? Or within several minutes, right? So you don't know what actually caused the problem. Where was the real issue here? And so that's becomes, and this is, as you know, when you get too many alarms, what generally happens is you actually start ignoring, right? Which is not a good scenario if you're a facility manager, especially if you've got critical alarms coming in, but you have a whole bunch of other alarms that are hiding the real reason for the problem. So let's look at what Guideline 36 does. It's called conditional alarming. So the same scenario is it knows when you had a chiller failure, it knows that. It still reports the alarms that you'll have on the rooms, right? But it just doesn't have it as on the main screen. It'll still record them, but you won't get the main alarm. They'll be shunted because it knows that the rooms, the air handlers, the VAVs, they know all these things are the problem, and your root cause was the chiller. And so I'm only going to send you the main alarm would be from the chiller because it's going to look at cascading the condition alarming across your portfolio. So this is new. This is a common problem in the industry, and I like to see that ASHRAE Guideline 36 was addressing this. And again, kind of the note at the bottom, they're shunted, they're there, but they just don't fill up the alarm screen. So how do we define the faults? So this is another big deal within Guideline 36. And I'm going to say Guideline 36, but actually if you follow ASHRAE's 90.1 2016 or greater or sooner, you will find fault detection is also part of that guideline as well. Okay, so this is nothing new other than they've expanded the list of faults than what the ASHRAE 90.1 has. ASHRAE 90.1, if you look through it, is really around the air handler faults. This gets into a little more granular into other faults. So let's take a look at this. They outline the different faults, and again, we're trying to do this for the different systems as they become available. It talks about the different operating states. They don't apply, and these are in addition to your alarming, right? This is in addition to something actually breaking to find out what's really happening as a root cause analysis. There are 15 faults that are defined. So when I say that, the guideline is set up in sequence that the entire sequence of operation actually defines these faults, and there's 15 of them. And let me give you an example of some of these. Duct static pressure is too low when the fan is in full speed. So this gets beyond just, oh, it's meeting set point, not meeting set point, or it's meeting set point, but yet we're wasting energy. This gets above and beyond that. This is the faults of where we're seeing the issues. Mixed air temp too low. It should be between the outside air temp and the return air temp. Too many changes in operating state, cycling on, off. For example, supply air temperature too low should be higher than the mixed air temp. Outdoor air fraction too high or too low should be equal to the minimum outside air. Supplier temp too low in full heating mode. Supplier mixed air should be approximately equal. Outside air too high for free cooling without additional mechanical cooling. So these are the type of things that are getting into the root cause of maybe I've got a program problem, right? Or maybe I've got a sensor problem. More than likely, it'll lead to a sensor issue because if you're following Guideline 36, the code and the program should already be set up. And you get the idea, right? So you get a number of these faults that are going on here that are being written in here so that you can see how we're doing with this. Now, it doesn't mean you have to use Guideline 36 faults. There are third-party, cloud-based, premise-based systems out there that'll also pull data points out of your BMS to do fault detection. I like the fact that these were built into Guideline 36. That way, if you follow the standards as a manufacturer, this means that at the start of the job, you actually can get these faults in your project. If you do third-party type applications, then it probably is going to be done later on because there's typically a reoccurring service or fee involved, and that typically involves service contracts and so forth, which is typically done with the facility management, right? So if you're a facility manager out there, which you are, then you typically you're dealing with some of that right now. Okay, is what is the extra cost to doing third-party fault detection versus doing it within the code? So let's do a recap. We got 45 minutes into this, and that'll allow for some Q&A here in a few minutes. So it was created as a high performance and energy efficient BMS control system. Okay. The idea was having this as this is the norm versus the exception. And again, we kind of talked about the legacy control systems may not be able to support this. That goes from a IP versus MSTP configuration on the bandwidth it's going to put on the network. That goes back to the application specific controllers versus advanced application controllers that have memory to them. So advanced application controllers typically have custom programming you can do in them. It supports COV, has local trending, alarming, has memory storage. The CPU typically with those type of controllers can handle Guideline 36. So those are all the things to think about when you've got an existing system. If you reach out to us, I can walk you through. I review tons of specifications out there that have application specific controllers in there. And that's going to be a big caution for going forward in the market for Guideline 36 and other energy codes like ASHRAE 90.1. And I say all those, I'm also not going to pick on ASHRAE as much as also the IECC, International Energy Conservation Code, is also starting to have these now involved as well. Guideline 36, it attempts to put a standard of a high performance sequence so that the manufacturer actually provides this to the integrators, okay, and factory offices. That way they're not having to add a cost on the job itself. You'll get where when you start seeing Guideline 36, hopefully you'll get some references to which standard they're going to follow, the trim and response, the economizer, the fault detection, the alarm mitigation. Those are all the things that could be applied to your sequences. And it does not cover, so there's still a lot of things it doesn't include yet, and we kind of talked about some of that. I believe the dedicated outside air system is being released now, and it doesn't cover DX units. And again, the water side of it is just now getting finished up. In fact, there you go. Expect DOS at the end of the 2024, and you can really pick or choose. Again, I do want to emphasize it is a guideline, not a standard. So it's not something you have to do. It's a guideline to how to meet some of the energy codes, right? And how to guideline of how you can improve your indoor air quality. So that's where a lot of folks get tied up in is do I have to follow the whole thing? No, you can still pick and choose. The more you pick, the more it's going to be efficient for your facility and your building. And then you can see for us, we're actually ASHRAE and our spec designer tool that I gave you a link for in December timeframe, we're actually adding the water side. We're finishing that up as the guideline has started to release those. And so we're going to add more sequences today. If you go to the spec designer tool, there's sequences in there and there's points list based on the air side for the ones that are available in ASHRAE Guideline 36. Again, you'll find rooftop sequences. They don't exactly follow Guideline 36 because they haven't released that sequence yet. So you've got some areas in there to use, and we're developing the tools with our engineering team as we go through this every year. So that's it. I promised I would be done in 50 minutes, and we're right at 50 minutes. So we do have some time for Q&A. Kim or others, is there any questions that I need to answer from the audience before we end? I'm looking in the chat. Okay, here's one that pops up. You mentioned legacy products may have challenges with Guideline 36. I hopefully went through that a little bit. You could still reach out to us and I'll get through that and walk you through it. There's a lot of factors. Really, the rating on the controller is probably the biggest factor. If you have application-specific controllers, and how you know that is you could go look at the O&M manuals of what you have in your existing building. If it's a new construction project, look at your existing spec or the spec that's out for bid and look to see if it has application-specific, especially on the air side, air handlers, terminal units. And especially while you're at it, you might as well pick on central plant equipment. You want to make sure those are all advanced application controllers that make sure that if Guideline 36 isn't acquired or developed as part of your job today, it could be added later. So those are probably the biggest things you can check on by just checking your data sheets, specifications. The more harder challenge is if you have MSTP or serial backnet installed in your building today. What is that what does that look like for putting in IP? That's probably a one-off discussion on, depending on your network, depending on how it was laid out, and so forth. So a lot of complexities to this. Reach out to your typical or your current service provider, and hopefully they can give you some guideline on that. Any other questions? Let me look at the chat here. Oh, here's another question. Can I pick and choose what sections of the guideline to use? The answer to that is yes. You don't have to incorporate all of it. If there's a section you're uncomfortable with, you don't have to use that. Though, obviously, the guideline was for you to implement as much as you can. Reach out to your service provider, reach out to your consulting engineer, find out what your building can do and can't do, and what's easier or harder to implement with your existing system. And you can figure out what parts you could use, but you could use it in parts or pieces of the entire standard. Let's see what other questions we have. Any others? Okay. Well, thank you very much. I don't see any others, any other questions on the call. You've got a couple contacts to reach out if you have any more questions on anything else. Thank you for your time today. And obviously, we did this before Halloween, so we didn't want to do this on a Thursday. So hopefully, enjoy your Halloween and be safe and prosperous out there.